institutional links project, which is a small scale research grant. So there are Newton advanced fellowships, there are Newton workshops, but the Newton research grants actually a project which is basically requires that you have already some sort of initial collaboration with the partner institution. So because we have some works done, or we have been communicating with Newcastle from time to time. We have signed before MOU with Newcastle. So this is something that has not started from scratch, but things that have initiated from small scale collaboration before. So again, the Newton institutional link program is designed to establish links beyond the level of individual researchers. So here, that's why here we have a group of researchers working with another group of researchers from two institutions, mainly from the host universities in UK and then here in Malaysia. So it is towards opening up opportunities for more sustainable, solution-oriented research and innovation collaborations between academics group as well as with the private and third sector. So here we have IWK Malaysia and Northumbrian Water on the other side as our private collaborator. So here the local partner again is, MITE. And this is the joint application, which is actually applied by UK side. So by Newcastle. So the duration of the grant is somewhere between 1 to 2 years, but the one that we have right now is 2 years. So this is the size is between, for Newton institutional link, the size is between 50,000 pound to 150,000 pound. We get somewhere in the middle. It has to depend on thematic priority areas. The one that we apply is under climate change and sustainability, and specifically it is under health and life sciences. So as you can see from the title, it conveys the word health. So our project again entitled Improving Community Health in Malaysia Using Sustainable Decentralized Wastewater Treatment. So it is on the thematic or on the focusing on health, but we're also looking into the environmental part of it. So Synopsis, to give you an idea of the projects. So again, this is a collaboration between Newcastle and UTM, and as well as IWK. In terms of IWK, we did the testing, we collect the data from several IWK treatment plants to provide some insight about decentralized wastewater treatment in Malaysia. So in this program or in this research project, what we have done is actually collect few samples for a period of around 8 months from small STPs owned by IWK around Skudai and Senai area. So there are, if I'm not mistaken, 8 in total that have been, we have taken sample from these small scale wastewater treatment plants. So small scale being under 10,000 population equivalent. So here is more on, because here the word health is being emphasized. So we would like to track the performance of this treatment plant in terms of reducing antimicrobial resistance, exposures, and so on. We would like to see whether how does it compare before and after the treatment process. So since Newcastle also have a new technology in terms of improving the removal of the AR genes and so on. So we also compare this performance of these wastewater treatment plants with the technology owned by Newcastle, which is the DDHS. So we compare it based on several parameters, microbiological as well as the normal wastewater effluent. And based on this study, we also evaluate the environmental performance of these technologies to see in terms of environmental impact, which are the most sustainable that you are actually removing this, but at the same time, you're not putting much burden on the environment. So again, this is between two universities. These prior to or at the beginning of the project, we renewed the signing of MOU between the two institutions. We have a long history, Newcastle and UTM. I'm also graduated from Newcastle, my master in PhD from Newcastle, and we have several in fact, our previous VC was also graduated from Newcastle. So this is basically actually renewing our vows, if you like. So this is what happened at the beginning of the projects. So these are, we have in particular 5 projects objective. The first objective is a shared objective between the two institutions. And the second objective is actually owned by Newcastle in terms of this objective has to be fulfilled by Newcastle University, in which in the second objective, Newcastle is responsible in terms of providing the capacity building. So Newcastle has conducted, as David pointed out, a workshop, the molecular workshops done in Newcastle Medical School in Nusajaya, in Iskandar Putri, to train the researchers involved in this project in using the advanced technique to detect the argin and so on. And then the third objective is actually to quantify the performance of the treatment plants based on the normal wastewater effluent parameters, as well as based on the AR bacteria and genes. So this third objective is done by both institutions. So meaning that UTM actually analyze the performance or the removal performance of the based on the normal wastewater effluent parameters, whereby NewMed, because here in these projects, the research part is from Newcastle University is conducted in Newcastle, in NewMed, which is the Newcastle branch in Iskandar Putri. So NewMed, they did the argin analysis and so on. The fourth objective is actually objective owned by UTM, whereby in this process we did some assessment based on life cycle approach to see which treatment plants actually have to quantify, if you like, the environmental performance of this treatment plant, including the new technology owned by Newcastle, which is the DDHS. And finally, the fifth objective is what we're currently doing at the moment, which is to actually share our finding and provide some insights in terms of what we have obtained from this result to benefit the larger audience in Malaysia as well as Southeast Asia. So these are our collaborators. These are my researchers. As I pointed out in the previous slide, we have different objectives. So different objectives bring actually different findings. I have 1 more minutes, and also, so we will have throughout the 3 days, we will have different sharing sessions whereby our researchers will share our finding based on the different objective. Okay, so just to show quickly, just to show what we have done, actually evidence that we have done the job, and these are the objectives conducted by Newcastle in NewMed. The capacity building, these are the wastewater sampling. We have provided our staff, our researchers with the right gear. The sampling was not conducted during COVID-19, so don't worry, no one was exposed to any harm. These are the fourth objective, where we do the assessment of the environment, we quantify the environmental impacts of the different treatment plants, as including the DDHS, and that one will be shared on the 3rd day by my researchers. And I'm running out of time. So that's it. If you should have any question, we can answer those questions specifically to the research throughout these 3 days, or you can post them on the chat sessions and we will collect them. If you leave your contact detail, we will get back to you on those questions, okay? So thank you very much, and I will pass to the next, to the Madam Chairperson.
Okay, thank you, Professor Zainura. Without further ado, I now call upon Dr. Shavini to moderate the next session. Okay, Dr. Shavini, the floor is yours now.
So good day, everyone. I'm Sharmini and I'll be your moderator for today's session. Newton-Ungku Symposium and Webinar 2020. The theme of this symposium is improving community health using sustainable decentralized wastewater treatment. So this work was supported by the Institutional Links Program under the Newton-Ungku Omar Fund Partnership. The grant is funded by the UK Department for Business, Energy and Industrial Strategy and Malaysian Industry Government Group for High Technology, MITE, delivered by the British Council and MITE. So before the presentation begins, allow me to introduce our guest speaker for today. Our guest speaker is IR Muhammad Taufik bin Haji Saleh. So IR Taufik is a professional engineer registered with the Board of Engineers Malaysia and currently is the head of planning and engineering in Indah Water Consortium. So IR Taufik obtained his Bachelor of Engineering in Civil from University Technology Malaysia. So IR Taufik's main area of expertise is in infrastructure development and sewage or wastewater management. So without further ado, I would like to welcome our guest speaker, IR Taufik, to deliver his presentation entitled Management of Decentralized Wastewater Treatment System in Malaysia. So ladies and gentlemen, please welcome IR Taufik.
Sharekan, tolong sharekan ni sekejap. Sekejap. Saya share screen, share apa ni? Presentation sekejap ya. Sorry. Share. Put on the presentation mode.
Okay. Assalamualaikum and very good afternoon. So, you are colleague I'm repeating. So today I will talk about the practice, challenges, and the way forward in managing small sewage treatment plant in terms of operator of the sewage treatment plant. So maybe we are quite aware that in Malaysia that we have a separate system where that the sewage going those generated from the household activities. So those the stormwater is going directly to the river through the drainage system. And a little bit introduction on the governance of sewage services in Malaysia. Basically, IUK is an operator who manages the sewage treatment plant, and we have under the Ministry of Environment and Water actually. So we have SPAN who regulate the sewage services in terms of the policies and planning of the proper sewage system, and we have Department of Environment who check and balance compliant actually, so that whatever design we need to meet the standard set by Department of Environment, and who regulate the effluent discharge. So UK is owned by the Ministry of Finance Incorporated, and we are only and maintain a plant, not own the asset. The asset is belong to the government. Just a brief overview on the asset dimension currently managed by UK. As of now, actually, so we have serves about 26,000 million of services about 66,000 kilometers square, and the asset that we manage now is about 7,000 number of sewage treatment plant, and we have about pumping of sewer pipe actually. So with the resources about staff, and because of the area of coverage is very wide, so based on the see that the green shaded with green is those area managed and operated by LUK. In the slightly the blue color is not maintained and operated by LUK. Actually, there's still few agencies running the operation and maintenance of the sewage treatment plant. It's not only LUK. In fact, there is also a few system which is considered as a private system actually. So managed by those have to get the license from the SPAN. Actually. So then LUK, we have a small unit office throughout the countries, and we have basically 5 laboratories to take the sample and analyze, and also to report to the Department of Environment. And we have a training center, and we have a small research center also to look into the initiative or areas that can be improved to make sure that the operation and maintenance of the sewage system will be more efficient and according to the standard or the latest technology that we have in the market now actually. So it's good to hear that Newton project is also looking into the capability into the capability of the small treatment plant to manage or to accept the emerging pollutant. So hopefully that we hope that with that study that we can we can be sure that we can be more efficient in maintaining and operating our sewage treatment plant. So just very set of the how we apply of the treatment plant is we only have 2 standard in Malaysia, A and standard B. So the standard A is for the plant that is just upstream of the water intake point, and the downstream water intake point, they have to comply to the standard B. So generally that standard A is more stringent than the standard B. That's why as operator that for the standard A area, basically those discharge to the water catchment area that we need to plan our operation maintenance properly. Basically that because the plant is, we have quite a number of plant, the small plant. So the priority sure that the plant will not give any impact to the environment. Basically for the standard A plant that we have, because we're not able to visit the plant on daily basis because the number is very big compared to the number of staff. What happened is for the standard A plant, we need to use to go, and also for the critical equipment, we need to put up the early warning system, whichever that when there is a problem occur the plant, for example that the plant there is a instead of waiting for the net visit actually. So how we manage the small plant actually. So this is some sort of the type of small plant that we have actually. So which is less than 1,000 population equivalent. So we have activated sludge, we have pond and lagoon system, feed film media, and septic tank. So those that highlighted in red actually. So this is a high number. For example, the acceleration we have about 3,000 number of plant, and the common septic tank. So we have about 3,500 number of septic tank. This is of course with the various type of treatment system, we have various type of performance of the plant actually. So that's why there is the study look into the various sample of the plant. So hopefully that we know that which one that capable to meet certain standard and which one that we need to improve further to make sure that we can handle the emerging pollutant actually. So some of the plant was constructed very much earlier actually before the existence of UK. So some of them are quite new actually, because in Malaysia that most of the plant is constructed by the developer actually, because of only the big plant normally funded by the government. The small plant actually the developer will construct for their own development actually. So we have quite a number of small plant everywhere in Malaysia. So in terms of the range actually, because I break down into 5 range actually. So less than 5,000, the 1,000 to 5,000 PE, 5 to 20, 5 to 10, 10 to 20, and more than 20,000. From this graph, you can see that actually for those below than 5,000, considered small plant actually we have about 80% of the plant is fall under this category. But the interesting part is that they are of the only 20% of the population equivalent served. Despite that the number of the big plant, for example, that more than 5,000, despite the number is about 20% of the total plant population, but this big plant serve 80% of the population that connected to the system actually. So means it's the other way around actually. So, but talking about the risk, I think of course we are aware that there is sometimes there's many risks in managing small treatment plant. For example, that of course because the small plant they are not subjected to the the fluctuates loading. Also means that sometimes that when we have the issue for example that we have all the illegal discharge, chemical discharge, excessive oil and grease discharge to the plant, and so this will give an impact to the plant because of the loading is slow actually. The impact is very high. You compare to the big plant, normally the dilution will take effect, and that's why you can minimize your issue actually. But a small plant, so once you have a problem actually, you are in trouble because you need to react very quickly. For example, the small plant, when you have the illegal discharge, when the plants are down, that you may take you 2-3 days to grow back the bacteria and make it survive and to able to treat the sewage as normal. Then issue of theft vandalism, because sometimes the plant is located at a very isolated area actually. So that's why, as I mentioned earlier, that we don't man the plant on a static basis or 24 hours. That's why sometimes that there is incidences that the theft is happen at a very isolated area. And the power outage also, again, that if there is sometime because the plant got tripped, so then nobody at the plant. That's why this is very risky. For example, those in the water catchment area or the standard A. So this untreated one will go to the river, and then we may interrupt the water treatment plant process. So what happened? How we manage the small plant actually? So normally that what practice now is we go for the, so then the small plant normally that we need to improve the performance and also improve the operating of the plant. Then why we go for installation? Because of the first, I think we need to look into the failure of the plant, whether it's structure failure or compliant or because of the aging asset. So that's why we need to get rid of the small plant. And sometimes because the refurbishment cost is very high, because instead of we incur high cost on the refurbishment, then we need to look into the rationalized, or we have to move to the better system or to upgrade the system. And also we have to look into the growth opportunities. If there is any development nearby that we can tap to the plant, instead of taking few 3-4 plant, maybe we can combine into one, and we can have a good system, better technology. So the restoration will also be set amendment if the standard is changed to a more stringent standard. That of course we need to do something with the plant to make sure that we comply to the Department of Environment standard. Factor is sometimes even though it's isolated but located within the housing area, from noise, odor, and also new flow to the
We would like to apologize for the technical error. So wait for a moment, yeah.
Okay, I continue. Sorry for some technical issue. So, have rationalization program and why we need to rationalize the plant, the small plant, and necessity to rationalize the small plant. Also, when the rationalization of small plant is possible. Okay, move to the next slide. Okay, this is example how we rationalize the small plant actually. So for example that we have a small sub catchment actually. So then normally when the plant was constructed by the developer, they will have a small plant for their own development. For example, for this figure, you can see that we have quite a number of small plant. What happened is later on that we will put the sewer line connecting the small plant, then end up we can merge to the one large plant actually. So this is how the mostly the government approach now basically. That's why we want to eliminate the small plant, because in Malaysia the small plant normally is plant that was constructed very much earlier. So then it have problem to meet the compliant, and also there is an issue because of the development surrounding the small plant already start coming nearer to that area. So there is a possible complaint from the public. So with that we can decommission the small plant and we bring all the flow to the new plant. So this is one of the example that we have done actually. So if those familiar at Pantai 2, because normally Pantai 2 previously this is just a simple lagoon actually, covering the 17 hectares of the land area. On top of that, there is also small plant connecting to the aerated lagoon. So once there is a fund from the government actually, so then we have transformed the aerated lagoon to the new mechanized plant. So which is using the latest technology, and also we have the all sort of element like the granted element, and the plant is already can design to meet a very stringent DOE requirement. So this is how the result of the restoration program, because with this brand new plant, the large plant, we can decommission or close down few hundred of small plant. So basically the national sewerage services objective actually. So the objective first is of course provision of basic service facilities for all areas, rural and urban. So we want to gradually minimize the ineffective service facilities by rationalization, then increase connected service facilities, increase the general service system means that we want to put more regional plant, big plant compared to putting the small plant. And comprehensive and sustainable management of service systems means that we have to take care of the life cycle cost and also the green tech element, and also to improve environment and public health status. So, but in Malaysia, that the sanitation I think has progressed quite good. For example, that if you look at back before the independent, that we are still using the very primitive system, but over the years that we have slowly address the public health, then we address the river pollution, and now it's time to address environment and also the water recycle or whatever reuse that we can use. Normally the gas from the plant, the effluent for the water reclamation plant, and also the biosolic to so based on this transformation, we can see that based on the research, it shows that the waterborne disease has been decreased, I think very low to about 1%. And also we have slowly reduced the number of the unclean river. And also in terms of the asset also, then the asset of the service assets has grown about 30 billion from earlier before the 1950s. So Malaysia, in terms of the sustainable development goals, that I think we have done quite good and improved because of the two aspects. For example, the population using at least basic sanitation services, we have gone to about 99.6%, and also for population using at least basic drinking water services is about 96.4%. This is reported based on the SDG, I think the globally 2015. So this is how we have improved basically in managing the small plant. So the intention is for us to move forward from the to reduce the number of small plant to the large plant through the rationalization process. I think that's all for me. Thank you very much.
So thank you very much, Ayar Taufik, for addressing this interesting topic. So we apologize again for the inconvenience caused just now. So all right, ladies and gentlemen, now we come to the Q&A session. We have about 5 minutes. So don't forget to mention your name and your origin. So any questions, please? For those joining the session through Zoom or the live stream, please ask your questions in the chat box.
There are around 3,500 septic tanks are there.
Yeah.
Still there. And I presume most of them Sabah and Sarawak. I presume that mainly in Sabah and Sarawak.
So actually it's not correct because the 3,400 is those in Peninsula.
In Peninsula.
And because in Sabah with Sarawak, we are not there yet actually. So we are only in Labuan. So the 3,400 number of communal septic tank is located in Peninsula.
In Peninsula. So that I think that's a quite big amount of septic tanks still there.
Yeah.
So,
but the number of the individual septic tanks is about 1.3 million.
That's why I'm wondering.
Yeah.
So should be more. I thought this.
Yeah. That means the figure that I share is those under LVK. So it means that there is maybe few thousand managed and maintained by the other agencies actually. So for example, like the last time we have the Dara, Ketengah, Felkra, Felda, that one is not under LVK because LVK coverage area is only for those within the local authority.
Okay. So like you say 1 million.
1.3 million individual septic tanks.
I think IWK is around 3,500.
The 3,400 is communal septic tank. Communal septic tank.
And one more question. Yeah, I saw one USB.
Yeah, USB.
After
Yeah,
research,
yeah,
There's one.
yeah. One.
So may I know what that plan is?
Because
Which area is it?
because the plant normally is designed based on span, the next the water commission actually. So then, of course, in the guideline you mentioned a few treatment system that means can be used in Malaysia. But sometimes UASB is not specifically mentioned in that guideline. So that one is sometimes that there is some, for example, the system supplier, I mean they want to test their treatment system, they must go through span and get the special approval actually. So that's why you can see that the most common one is the extended duration because that one clearly mentioned in the guideline. So that's why, and also for the operator also, for us that extended duration is the most so-called that the not to say easy system to manage and also more efficient in terms of the compliant, in terms of the operating cost actually. Yeah.
So, okay, we will end the Q&A session. Thank you, IR Taufik, for the insightful input. And let's once again give a big round of applause for IR Taufik. So a gentle reminder, kindly fill in the attendance and perception survey Google form. So for those who are attending the event physically, you can scan the QR code at the entrance of this meeting room. While those joining through the live stream or the Zoom, kindly access through the link that have been shared in the chat box. So before we end this session, we would like to play a short video on Pantai 2 sewage treatment plant, which is located in Kuala Lumpur. So this video shows the construction process with the latest technology from beginning until its completion. So a humble request to remain silent throughout the video. So let's watch the video now. So, all right, this session will end here for those who are joining us through the live stream. Thank you for your attention.